All right, so application number 12, week 9. And let's copy the whole thing in. Gotcha. All right, so confidence interval is what we're doing here, and it is a mean. So confidence interval for a mean, the population here is all tips at a restaurant. And we are trying to estimate the average daily tip. So that would be our parameter. So that is an X bar, which according to the central limit theorem is one way, the best way to approximate the population mean. So we have a particular day or sample from particular days, and we're trying to estimate the average daily tip. What else do we need to know? We have a confidence level here, and that is 98%. Alpha is always 1 minus the confidence level, so that would be 2%. Oops. And then the tail probability is always alpha over 2, which is where the z-score comes from, and that would be 1%. So if we just double check that with StatKey, a z-score, by the way, always has a center of 0 and a standard deviation of 1. And so if I use the StatKey normal distribution, I would reset the mean to 0 and the standard deviation to 1. And I want to know, let's say, left tail or right tail, what's the z-score if we have 1% in the tail? And it says it's about 2.327. And if I look back at this problem, it says it's about 2.32635. So we have an interesting, slightly different rounding. And then I should get the same thing on the other side, just the opposite. So if I threw a left tail in here and I put 1% in the tail, I should get about the same number. So those are our number of standard deviations on each side. So the next thing I have to do is make a sketch of this and figure out what that means for the tips. So new page here. And blue is fine. So let's start sketching out our confidence interval. Draw your best bell curve with a line in the middle. And in the middle goes my sample mean, which is 3.849. This is an important distinction. When we're doing confidence intervals, it's the sample that goes in the middle. If it's a hypothesis test, it's the null hypothesis, which is an estimate of the population that goes in the middle. And that is a tough one to keep track of, which is which. And then we're going to about 2.3 standard deviations on each side. So that should be about here-ish and here-ish, so that we have 98% in the middle and 1% of samples out in each tail. Z-scores are a measure of how far are we from the middle. So a z-score of 0 would be right here. And here I pre-calculated for you the z-score that marks these tails. So that would be z equals about 2.32. Mine shows 326. I'm going to go with that version of it. And we can do this on the spreadsheet too. So what's the point estimate for the mean? That's always the sample mean. So we're estimating that the population mean is the same as the sample. So that would be, switch color, 3.849. And then the margin of error on the mean, the formula for that would be, let's see, we don't have let's see, I'm saying we should use a z-score here. We probably should have used a t, but I'm going to go with what I said there. So that would be the z-score times the standard deviation divided by the square root of the sample size. And so we can calculate that, and StatKey can calculate it for us too in a couple of different ways. So we'll check both of those. So spreadsheet time, let me write these numbers down. N is 157, X bar is 3.849, and S is about 2.421. And we're 98% confident. So do I have that spreadsheet open? So confidence intervals with spreadsheets, this is a mean. And I claim to use a Z in this case, probably because the sample size is relatively large, so we have to switch to the right tab. That's important. If you use the wrong tab, you get the wrong results. And again, this picture relates to this situation, so we're doing a whole new situation. So I better make a copy of this so I don't mess up the original. Copy, sure. And you'll need to make a copy for yourself, but you don't need to continually make copies. You can just keep reusing the same one. All right, so again, I want a Z interval is what I was asked for here. And my sample mean was 3.849. My sample size was 157. Population standard deviation I don't have. I'm going to have to use the sample instead. So that was 2.421, and that's a comma, not a point. And so the standard error here should be about 0.19, so about 20 cents. And confidence level, ours was 98, so 0.98. So once I replace all those values, this should calculate everything else. So the critical value, that's that 2.32, in this case it says 6, which is what I pre-calculated for you here in the problem. And where'd I go? Here. Nope, wrong one. Here. Yes. And then this calculates the margin of error. And if I hit enter to see what, there we go. It's grabbing there. So it's saying, okay, go grab the D12. What is that? Oh, the Z-score above. And then multiply that by the standard deviation and then divide by the square root of the sample size. So that's that formula I just stated. And then it will calculate these numbers for you by doing an addition and subtraction. All right, so then we think the tip is going to be somewhere between 3.3, so about $3.40 up to $4 and what's that, $4.30 roughly. The average tip in a day is somewhere in there. Now, individual tips will vary greatly from like nothing. Sometimes people don't tip. Sometimes people give wicked big tips, like there might be a $20 tip in there. So don't confuse the range of values for an individual tipper and the average over a whole day. Because anytime we take an average, we get rid of the maxes and mins and we narrow it down to this single number. So this is a range of possible averages, not a range of possible tips. So what do I got? They probably want 3 decimal places. So 3 point, if I round that to 3, no matter what, it's 0.400. And then the upper value is 4.298 would be my confidence interval. And I had started a sketch over here. So a Z-score of 2.3 correlates to a tip, an average tip of about 4.298. And a Z-score on this side of negative 2.326 would correlate to a tip of about 3.400. And these are tips, dollars, dollars, dollars. Right? Average tip. Probably should have wrote in dollars. So my error bound, let's see, I forgot that what that was. Show my spreadsheet. That was about margin of error here, 0.449, so about 45 cents was the average spread. Not for all tips, but for an average tip. That's super important. So if I label that in the picture, I'm kind of running out of room down here. Let's put it in green. So that's about the distance from here to there, or from here to here. So that's the error bound on the mean is about 0.449. So that's my margin of error. And my confidence interval would be parentheses 3.4, zeros don't matter, and then comma 4.288 for mine. And then I would want you to screenshot this or take a picture of your paper with your phone and then upload that picture for me to take a look at later. Let's see, is there anything else we should say about this? Oh, what would our interpretation of the confidence level be? Let's write an interpretation. I don't think I asked for it in this problem. I just asked for a picture. But on the final, I'm definitely gonna ask for an interpretation. Oh, I think my pen finally died. Yep, wow. All right, let's see, is there a typewriter here? Really, this guy doesn't have a typewriter on it. Oh, I do have a typewriter. What happens? Ooh, what the hell? Sorry, I never clicked that button before. What is that button supposed to do? Virtual keyboard. Doesn't work. Okay, we will go somewhere else and type this up. I'm definitely not going to try and write the language with my mouse. So let's go in here. So this is about average daily tip. And then I need to write a sentence. Let's blow this up a little more so you can see what I'm typing better. Hopefully that's big enough. Okay, so we are 98% confident that the average daily tip at this restaurant is between, now let's jump to a new line, $3.40 and always make sure you have the units in there, $4 and let's round it to 30 cents. That's what that would round to. Boom, done. That's it. That's the interpretation. Another way I could state that, just for fun, is we are 98% confident, and I want most of that, but not all of it. Instead of between, I could say within, and then I would state the margin of error in the middle. So within about 45 cents of, what did we say the mean was? Where'd you go? 385. Oops. Within 45 cents of 385. And the within, right, that means the whole plus or minus thing. So that'd be another way I could interpret that. All right, we are after 11, and I answered all the questions people asked about for now. So I'm going to stop this here. If you have further questions, check